Ring ring.
Ring.
New phone, who dis? No, it's streaming. Okay, now we're seeing. Let's see. Let's not show that also. Let's get this up. Come on. Let's refresh this. Whoa. You what?
Right.
Alright. So okay, so no you, Seth. No you. Okay, bitch.
What? What?
Seth, can you make posts? Seth, make posts. Be like, yo, we're live. You think you can do that? Can you do that for me? Huh? Can you do that for me? I think that answer is a yes. See if anyone like just floods in. Oh yeah, look at that. There's a few people who just like are here. Thank you. I appreciate it. If you want to be added to the call, you just let me know. Anyways, what are we doing?
Things.
Okay. Yeah, I really quickly wanted to go over kind of what's going on. Real quick. Like, what did we do? What have we done? We've done a lot.
What do?
Mm-hmm. So, anyway, I'm gonna wait a few minutes here. Gonna get the game open. And we're gonna go over some things here. Yeah. So I want to actually see. I want to see some interaction in the chat today. I want to see hellos and people's. What's up?
You figured this.
Ring ring. So.
And yes, it is me. So, Seth. Bye.
Hey yo. So, oh, right. I was dealing with this a minute ago. Yeah. Okay. Let's not look at this right now. Let's look at.
No, look at it.
No.
Look at it.
I'm gonna do this. I'm gonna do.
Look at it in all its glory.
No, I clicked the wrong button. Oof, not responding. Alright, cool. Sweet. Alright, so what we've been doing. So, real quick, what we've done here is something that's kind of cool. So let's really quickly get our files open here. So really quickly in the base, we have a new kind of restructured code kind of format system here. By the way, this is going to be DVR'd, so there should be a VOD of this. So really quickly here, we start in our main, which is all of our G buffers. This file here handles everything within the world 0 folder. All of the shaders are loaded through the world 0 folder just to prevent kind of like, so whenever we go to like multi-world things, it just is already set up to go. And then in the root of the shader folder, we have all of our main files here. So to start here, we have our main here, which outputs to buffers 1 and 2. Actually, here, let me also get up the sheet for the data flow. Sheets. I think it's this one. Let me really quickly move that off screen though. I don't want to pull up. Yep, that was it. Okay. So this here is the data flow for Continuum. I know it looks a little confusing, but TLDR here. Reds means reading or writing rather. Blue means reading. If it's black, it's not being used. And if it's red, that means it's reserved. There is data in there, and we do not want to write over it. That means no touch. So we have a bunch of our G buffers here, and we render a lot of these solids through them, and then it just passes through the deferred and the translucence, and this is for the albedo. So this holds like all of the, yes, it is Firefox. It holds all of the color information for the solid, so anything that's not water or stained glass, basically. So this is reserved in the color text 1 A buffer. So in Minecraft, or rather in the shaders mod, all of the buffers that we have are double buffered. What this means is there's an A buffer and a B buffer. One of them is read from, one of them is written to, and they flip each pass going down the program here. So what we do here is we take into A, and then we read from A, and then we write to B. So like in a classic sense, it's like this here. So we write to A, we read from A, we write to B. We read from B, we write to A, we read from A, we write to B. So it just kind of goes kind of like this. It flows like this. It just flows through. And sorry, just give me 1 second. Seth? Alright. So, anyways, what we can do though is if we force certain things to flip and we kind of take control of like how this all works. They've been abused by these two gods. So what we can do is we can actually have 2 buffers for every buffer, basically. We have an A and a B. The only caveat is if we write into A, we cannot write another thing into A if we want to access it, and we can only access A or B at one time. So, like for example here, we write the solid albedo, but we have it reserved here. That's important because we read from it in composite 0 to start our first pass of solid lighting. So we light all of our diffuses, all of our diffuse and everything else first in the composite 0 pass. And what this allows us to do is whenever we calculate reflections in the next pass, we have all of our lit information. And also whenever we composite, we have a composite glass over top, and we want to composite it over top a lit rendered image. So like, for example, the sky would be behind there, a lot of other things. Anyways, what else? So then we flip through, we write, so here's a case where we flipped something. Normally all of the G buffers would write to A, so they all overwrite on top of each other, and they just update the pixels as it flows through. What we did was we flipped it into the B buffer, and what this allowed us to do was, assuming that we didn't write to the buffer in composite 0, we could save that data until later, and then we could read from it in here. And we do something very similar for all of the data. So in composite 0, we just want the normals and everything else. Yeah, big rip. Big rip, big rip. Well, I mean, this is gonna be a technical stream, so I mean, I doubt many people are gonna be like super into it.
This is a big old how to make fast.
Yeah, this is how we've been working to make everything super fast. So what we've done here is this is our data pass. So this holds all of our like material information, our light map information, the normals, like the reflectance, the emission, all the things like that. And this passes everything down. It's great. However, this is different than the A buffer. In composite 1, or color text 1, sorry. In color text 1, we have the solid albedo, and in composite we just want the solid albedo, and in composite 1 we just want the translucent albedo. We don't want them to touch each other at all. But in this case, we actually do want them to touch each other. In the composite 0 pass, we only want the solid information, but in composite 1 we want both of them combined on top of each other like it would be normally. So what we did was we used the deferred pass, which goes in between all of the solid G buffers and the G buffer translucent. Generally in our testing, this is an extremely slow solution. However, whenever you just use it as a pass-through buffer, it really doesn't add any extra overhead, like if at all. well, any more than you'd expect for a copy from A to B. So what this does is it reads from A and then just immediately writes that back out to B. So it updates both A and B to have the same information, and then we write the translucent information on top of that, so we get both of them combined written here. Then if we continue going down through the pipeline here, you can see that we don't write to color text 1 at all after this. There's no writing. You can see that we write the lit world LOD through here, and then we also write out the depth of field bokeh weights. So this is like the bokeh shape. Looks a little something like, let's see here, bokeh. Sorry, there's no settings. Bokeh, look at yeah, okay. So for example, it's, oh, that got broke. How'd the bokeh debug break?
I have no idea. I touched it.
Blame Jake.
Oh.
Well, here, we'll go to the base. It's fine. I know it works in the base.
Robo, but
I know it works in the base.
I feel unloved.
You do. You are. We'll turn off TA and then we. Oh no. Oh no. Okay, there. Where is?
Get Rick as well. Stop sending too many messages.
Debug. So there you go. In the bottom left there, you can see the bokeh. So this is the shape of the camera. Let me turn up the samples a little bit. I really should just be in the code to do this, because this is terrible.
So when are we gonna get a 4K 60 FPS stream?
I don't even have a 4K monitor.
I don't care.
So anyways, so yeah, we can crazy turn up the samples and lose all the FPS. Anyways, you can see that we have a very disk-like. Yeah. So that's what that is in the bottom left. So that's what we pass down in that buffer there. So we actually don't do a. I need to update this actually.
How are those things in the wall?
We'll do PP0, and then we can do final /1. Okay. Anyways, this isn't blur X, it's just blur. Let me do off. Okay. Anyways, so we write out DOF after reading the bokeh weights in here, and then we calculate the bloom tiles. We read from a 16-bit buffer because we need to LOD it. We use encoding to merge all of our like our lit world here, our lit solids and everything else into a into an RGBE kind of format. So we use the RGB triplet as the standard color, and then we use the alpha component as a exponent to like a floating point number almost, kind of like the exponent to the Manasa. So the RGB triplet would be the Manasa if you're familiar with floats, and then the alpha would be the exponent for it. So it just allows us to store a huge span of an RGB triplet, assuming that the RGB triplet itself is kind of in a similar-ish range, which in our testing is almost always the case. So we take out the bokeh here, or the depth of field here. We combine it with the bloom tiles, so we have the blurred and toned image. We tone map it in this phase as well. Then this pushes it back out into the temporal anti-aliasing. This reads out the 8-bit toned image, and it calculates the over time frames, and it uses color text 4 as a read-write buffer. At the end of the frame, something kind of fancy happens. A flips to B, so everything always flips at the end of the frame. So in this case here, what happens is we just kind of flip-flop back and forth between having the first frame and the second frame, first frame, second frame, and it always flips into the right read for what we need. So we always have the last frame's information in this buffer until we combine the two together and push out again. So it's like constantly integrating over this same frame here. If you don't know how TAA works, you could look at one of the articles. I'm not really sure. Anyways, so that's the flow of the data through Continuum. It's a little complicated to get everything kind of down. But what we've done here is we've almost fourthed, if not more, the data usage for Continuum. We're still reading and writing a very similar amount. However, we've cut the overall space and the footprint of it, and we're definitely working on optimizing down all of the reads and writes as much as we can. So, yeah, that's pretty much that. Moving on, another things we're working on right now. So we've been working on doing the pre-computed atmospheric scattering. Currently, I really don't have much to show for it. I have the way that it works is it'll have it'll be a little application that'll be bundled with a shader. So it'll be in the folder with everything else. It'll be a little exe and a JSON configuration file. The JSON configuration file will hold all of the information that you would pass in for the sky. So very similar to the way that we have the sky settings set up right now. So like, you know, the no, get. Oh gosh, let's just, yeah, there you go. So these settings wouldn't be here, but things like the planet radius, the atmosphere height, these kind of settings here, the coefficients, the ozone coefficients, all of these things would be in this JSON file. Basically what would happen is you would run the JSON file and it would spit out a lookup table, which is a 3-dimensional lookup table that is, or rather it's a 4-dimensional lookup table that's baked down into a 2-dimensional image. So then the shader will take in this 2-dimensional image and it'll remap all of the variables, like the direction that the camera's looking, the direction that the light is coming in, how high you are in comparison to the atmosphere, and a few other things like this, just to kind of figure out exactly which colors should be where given whatever time of day or wherever you are, if you're wanting to leave the atmosphere or whatever else that might be. What this should do is it allows it to be a hell of a lot faster, for one, so we don't have to actually compute the sky every frame. It's already computed and it's just in a picture, and all we got to do is look it up. So that's really, really cool. It'll be nice. It should give us a huge performance boost in both the sky and also in the volumetric light. So what this is also going to help us do is also up the quality of the sky. So currently, the way that we're rendering it right now is we don't have the budget to do proper full multi-scattering. But what this would allow us to do is have multiple LUTs tied together in the same image still. So it would still be just one massive image at this point. And it would have all of the multiple scattered orders. So we could compute multiple scattering that's occluded through the entire atmosphere. So it would look a lot nicer, especially at like at sunsets and other things like that. Whenever the sun dips below the atmosphere, it'll look a lot better, and also it'll be able to tie into the VL a lot smoother as well.
Joey. When someone says that they asked if they're watching this at 1.5x speed, it might be time to slow down.
Yeah, no, I don't. Listen, I listen at 1.5 to 2x speed, and we're gonna talk at 1.5 to 2x speed. Let's go, vroom vroom.
I'm sorry, we shouldn't have gave him coffee today. Also interact with chat more. That's the request.
Okay.
There you go.
So yeah, so all that will be moved into the LUT generation, and that's just that. Beyond that, I have a new tone map, so that's cool. This one is not bad, and it is really configurable, actually. I really like the settings that are attached to it. Currently, I'm not very happy with the way that everything is looking here. And I really want to build some debug tools to better look at all of the data that is coming through here for our energy values. So Continuum 2.0 and 2.1 both utilize a full physically based like luminance system to derive brightness of everything. So like, for example, we define the luminance in space. We define the luminance in space, and then it goes through the atmosphere, all of the energy absorbs off, and everything eventually occludes into the final scene here. So all of our energy values should be in the correct ratios to everything else. What this allows us to do is be able to set common luminance values that are measured and easily like verifiable. It also allows very nice clean bloom, because it allows the blur kernels and everything else to match even in like exponential scenarios where large values are actually treated much differently than small values. This also lets the lighting be cohesive across different light sources. Even though in Minecraft technically there's very, very few light sources. There's the sun, the moon, and basically torches. Hopefully with Nova this can change and we can separate out like torches from glowstone to everything else. But as it's currently set up, all light sources in Minecraft are treated basically the exact same. So that's not great, but we'll get there. This is another thing that RT will fix. Is technically if anything can be bright, any pixel, so it would cast shadows and it would deal with everything else perfectly in the scene. But that's not what we're talking about today. It is raining, I think.
And ray tracing has its own issues.
Yeah, ray tracing does have its own issues, and I'll go over pretty much all of them and why I don't want the ray tracing to be the only version of the shader, because honestly, there are so many caveats and pitfalls to it that it's really not worth it. For a lot of cases, like general gameplay, I don't think would be very good. But things like cinematics, if you have proper like occlusion culling and being able to like actually transition frames well and cleanly, it'll be very, very, very nice.
Don't tell me what to do.
Yeah.
Okay.
So yeah, we're utilizing encoding in our vectors, in all of our buffers basically. Our main material buffer here is full with the normal roughness, porosity, the light maps, the emissivity, and you can see here that we leave matte flags here at the end here just because I haven't set up the system for it yet. You notice that we might not be passing F0 down through the pipeline anymore, and that's because we are going to be moving to a hard-coded F0 system. So essentially, if basically your matte flag is going to be able to be derived from the F0 values and the block IDs themselves. So let's say you have like a gold block. So you're on the gold block, and then you also set the F0 that of a similar value to gold. What would happen is it would change the matte flag to be gold, and it would render as just gold. We would have predefined settings in the shader because metals and things are complex for their reflections. They have an imaginary part. You have to compute them a little bit more in depth to get like a realistic look to them. So that's why we've opted to that, and that has allowed us to move porosity and emissivity through, which do need full RGB8 support throughout the entire thing. We have some new BRDFs that are going to be going into 2.1. So the current BRDFs I have learned are extremely, extremely, extremely bad. So sorry about that. Hawks and a few other people can attest that they look a little bad. They're a little bit like the wrong energy between the specular and the diffuse. It's very noisy. It just looks off in a lot of ways. So I since realized why all of that is, and I've come up with a completely new model, and I'm extremely proud of it. So this is it here. You can see it's driven by F0 roughness, porosity, wetness, and pore size. So currently the bottom half here is kind of disabled here. I have turned. You can see that the porosity here kind of does work in this case. You can tweak the pore size, but honestly that one doesn't really do all that much, especially whenever the porosity is low. So you can see here that we also have the roughness. This here is a GGX roughness that is fit to the GGX specular lobe. You can see if we move out all the way over to a metal here, you can see that it reacts correctly. The porosity still does affect it, so you can actually have a porous metal, which is kind of interesting. Technically, that's a non-PBR type value, but with the way that it's set up, it still kind of estimates it. We're also going to be adapting in wetness to everything. Currently, we don't have puddle generation. However, we will hopefully by the final release, and the puddle generation will be a 2-layer BRDF model that accounts for the refraction layers and also all of the pores. All of the pores within the microfacet surface. So like as water fills in, all of the lighting events will correctly occlude, and the energy values will all be correct as it bounces back out towards your eye, dealing with the thin water surface over that as well, or water entering the surface depending if it's a porous surface. So this should handle basically every case of weathering to a pretty much perfect standpoint. So I'm very, very proud of this. This is honestly my baby. This is probably one of the more advanced BRDFs out right now. It's very accurate. It's very fast. It uses very few instructions. I really can't complain at all about this thing. Anyways, so that should be in 2.1. 2.1 is going to have a little bit more blurring information going on for the specular. I don't know about GI yet. I really do want to get some form of GI in, but I really do need to look over some of different methods to fit it into the system we have now. Or maybe I'll do a comprehensive study on Arsene. So, besides all that, the filters are going to be spatiotemporal variance guided filters, similar to the path-trace denoiser paper that NVIDIA put out. Their version of it is very, very, very slow, and it uses 5 passes. It uses a 5-pass HROS wavelet filter. That's honestly, I don't think, needed for our situation. I don't think we're going to actually have that much noise, especially not for the specular. Specular generally is not all that noisy. And with the new ray trace system that I'm still rounding out kind of some of the details for it, so I'm not going to go into it too much. But hopefully I'll be able to send out 4 rays per pixel compared to the 2 rays per pixel that we're sending now by default, and it should perform around similarly. So it should look a hell of a lot cleaner. There should never be any noise or any like flares or anything else. The whole image should look clean. For GI and AO and that kind of thing, currently we're still going to be running with our GTAO method, our ground truth ambient occlusion that was made by Activision a few years back. It's pretty cool. We adapted it. We adapted the occlusion function for it though to the Alchemy AO philosophy. So we generate the horizon angles similarly to how Alchemy does, and it is extremely performant. And honestly, you don't even really notice the FPS drawback. We store the sky information in a lookup table for proper integration with the BRDF, so we can integrate over the entire surface. The sky map for diffuse is stored in spherical harmonics, and the sky map for specular is stored in an equirectangular projection that is the same resolution as the screen. There is the pitfall with the equirectangular projection of it being fit to the size of the screen is sometimes the FOV ratios can cause a small line to occur in the horizon map. However, if we set its energy value to 0, generally because of the fact that we're doing a rough temporally accumulated specular, most cases you can't see it. It's okay. If you really look for it on a very flat water surface, you could probably find it though. In the spherical harmonics though, we don't just do the sky, we also are going to be simulating all of the atmospherics, so like the VL, the clouds, all 3 layers of the clouds. I'll get into the cloud system in a minute here. All that kind of stuff. So it's really going to be kind of interesting how that all looks and works out. So hopefully, as weather moves through the day, everything should just feel right. Speaking of weather, we're going to be moving to a 3-dimensional wind volume kind of. I don't want to call it a simulation because it's not. They're not like rendering out individual particles as they move through like a fluid simulator. But what we are trying to do is create something that looks similar to wind and moves similar to wind through the world. It's going to be very close. What this should do is allows, for example, the water waves to be a lot less uniform. So it won't be the same tiling pattern over and over and over and over again. It'll be very varied depending on where you are. Hopefully I can get some biome dependencies. I know that currently the way that Optifine's set up, that we can only get the biome that the player's in. So that doesn't really help all that much. We could use that kind of information to drive the sky, but since we're moving to the LUT-based system, we can't do that anymore. So there's a few little nicks that I need to work out with the biome stuff, so I can get proper weather per biome. But this wind simulation should also be able to drive the local coverage clouds, so it should be able to find which cloud types are going to be in the area. We're going to have a few different cloud types. We're going to stick with the cumulus and the stratus. And I want to add in proper cumulonimbus clouds off in the distance in certain cases, and then also render them whenever it's actually raining. I do want to do local rain volumes as well. So technically, even if it's raining in the world, you could still technically be inside of a sunlit area where it's not raining, and everything would hopefully update correctly. I don't know how the sounds are going to play into that. It'll be an option. All the clouds are going to have local coverage, so it won't be like the entire sky is full of clouds. You might have it where one side of the sky is kind of cloudy and they're moving in, and the other kind of half is completely clear. The clouds will also be wrapping into the atmosphere, so you'll be able to watch them kind of like dip down into the horizon. So if you have a really large render distance, in the render distance, if your render distance is long and you're like looking at over like an ocean, you'll be able to watch like the clouds almost like go into the ocean, like they're going in for a bath. It'll be really pretty. So are we doing anything else? Oh, right, caustics. We're gonna be dealing with a lot of caustic stuff in 2.1. Hopefully both glass and water will have caustics. I should have both ray traced and approximated options available. For the ray trace ones, there's going to be a few caveats, and also for the other one, there's also going to be some caveats. Sadly, whenever you're trying to model caustics kind of perfectly, there's always going to be something that's slightly wrong with it that kind of throws it off. So it's a little hard, but we'll get there. With the newfound performance, we should be able to get, I don't know, hopefully in the end, it's going to be like a 4x performance increase. However, some of our effects that we're going to be developing for this are going to be a little bit slower, so it'll pull us down. The overall improvement, though, as we're trying to aim for, is after everything's said and done, we should get about twice the performance that we did in 2.0 and 2.1 with similar settings. And that's for everyone across the board.
So you 1060 guys will. 1060 users rejoice.
Yeah.
Me.
So, yeah, we are going to be dropping compatibility with Intel HD. It's just a pain in the ass. We're using a lot of modern features to make sure that everything is as fast as it can be, as it's as small as it can be. We're using a lot of encoding and a lot of weird, fancy stuff that you shouldn't honestly be using in something this old.
Really?
Yeah.
You said dropping. I thought it was fun. Our Intel HD compatibility is like a mess.
Yeah, but
Only
it's
works
we're not
for like 2.
yeah, we're not just no more.
It's never.
Also, in this version, we're going to be doing the dimension-specific shaders. So we're going to have custom fields for the Nether and for the End. So we are going to go a little bit more artsy with both of these, where the overworld is going to be quite realistic. I really want to have a lot of fun with like fogs and lights that are imaginary and other things in the Nether. I really want to give it a creepy like ambiance throughout the whole thing. I really want it to feel like you're, in hell. And in the End, I want it to make it feel like you're in like some weird place off in space, floating on some rock. Because honestly, I think that'll be really pretty, and I would enjoy doing that. I wanted to put up like a galaxy or something up in the sky. Sounds fun to do. The parallax occlusion mapping in this version should be a little bit better. Hopefully we don't get any more flickering with the TAA and the POM and everything else with the BRDF going black. The new BRDF should fix all that. We do have we have a much improved TAA. It's still not perfect. I think it still has some caveats, but we're getting closer. Hopefully by the end of the development of 2.1 alpha, it'll be in a pretty stable, near perfect state. As far as RT and Legacy go, now that the base is done, we can start definitely moving in some of our ideas. I can just give a really high-level overview of RT real quick. So RT is gonna be a path tracer. That's actually not. I'm not gonna final say that. I think I want to do. I don't know if I want to do like propagation volumes or full brute force path tracing, or maybe if I want to do like a mixed method. So if I want to like brute force path trace like the specular and then just do LPVs for the diffuse, just because it would be a lot cleaner of a diffuse. It's much more random and obscure for diffuse, where specular rays are generally a lot more uniform and it's easier to denoise it. So yeah, I really don't know. In this one, we are going to be utilizing NVIDIA's 5 wavelet HROS filter. that's variance guided from NVIDIA. Honestly, it is a gorgeous filter. It's beautiful in design. It only blurs just enough for the amount of variance that you have on the screen, and as rays resolve over time, the blur gets less and less and less, and it refines down a hell of a lot more. With the speed of the base as itself, this is going to give us a lot of headroom for the effects for this. Our goal is for it to be able to be run at least 30 to 60 FPS on fairly high-end hardware. Hopefully at this point we'll be shooting enough rays off every frame, and it'll be blurring well enough that really only for a very brief moment will it not be very detailed in its bounces. We will have options probably for infinite bounce accumulation and a few other things like that.
Shoot my rays, Daddy.
Yeah.
Mini rays, all the rays.
Yeah, mini rays. The goal here is to send many rays per pixel, multiple bounces per pixel, rather multiple bounces per ray, and also diffuse and specular, both passing down in the same system.
So minimum requirement RTX Titan. Right?
Yeah. Also, I do have a solution to a lot of the pitfalls of Zombie's method. Currently, the way that Zombie has done it is to handle the shadow mapping. He has fallen back to using default shadow mapping because of some of the complex geometry that is not a perfect cube. I think I've come up with a way to voxelize even complex, what's it called? Complex geometry, and be able to reproject it near perfect inside of the shader. So you'll be able to reflect things like grass and anvils and like leaves and all that kind of stuff. It also would allow like vertex deformations and things like that. I want to adapt it to path trace through water waves. We're going to be doing proper ray traced caustics through there that scatter out through. I found a few articles on rough transparency. So you could have like frosted glass and imperfect glass and things like that with scratches. So I'll be looking into that. I don't know how well that's going to all tie together. The performance of this thing is going to be very finicky. Sending all of these rays with all of these extra cases gets very expensive very fast. So I do predict that this thing is going to be probably more geared towards cinematics, where you're probably even going to want to record in like 120 FPS, if not more, and then slow it down or speed it up or whatever else you need to do in post to make sure that you're getting mini resolves for a clean image. So be ready for that. And if it looks really good in a cinematic and it doesn't look as good in game, that's why. It's because it's recorded at a ridiculously high frame rate, and because of the way that the light accumulation works, it will hold it around. I do have a solution to one of Sonic Aether's pitfalls in both of his methods. Currently, because of his infinite bounces, whenever you update any of the blocks, it does take quite a few frames for it to realize that it's actually super dark. So what we need to do here is we need to add some pre-raycast checks to see exactly which areas need to be updated. So with this won't update the whole scene whenever you break a block, replace a block. This will just update the rays that are affected by this block itself. So it'll be very nice. It's going to require a separate data structure entirely to march through, but that's okay. It's going to be very interesting to see how that goes. So it should have pretty much every effect. I'm going to be looking at proper multi-scattering in clouds, and then proper sky integration. I'm probably going to use LUTs for both the clouds and the sky for RT as well. In 2.1, I don't know if I'm going to be using LUTs for the clouds. I might use a similar method now. But that is all the current stuff that's going on. Legacy is going to be just updated 1.3 with performance. That's pretty much it. Literally, it's gonna, and TAA. That's literally it, though. Another thing with the base is we're trying to push the settings a lot further than we have before. So in 2.1, we have overrides for a lot of the settings and functions. So For example, another shader developer could come in and basically make their own version of Continuum and send back out their own user libs and share them to other users in packs or whatever else. And that would be a completely legal way to redistribute like modifications of Continuum, and you can actually you will be able to go really in depth with this kind of stuff, like tone maps, lighting, whole 9 yards, shadowing, whatever else you want.
Kind of like EMB presets.
Kind of, yeah, but yeah, pretty much actually.
A lot more detailed, though.
Yeah, a lot more detailed. There's also going to be a lot of debug options for anyone who's going to be doing that. So we're going to be having like readouts for energy and histograms and graphs and a whole bunch of other shit that you can output to your screen to verify that your tone map is outputting in full range, that it's compressing down the right ranges, you know, how bright is the sky in the scene, how bright is the sun in the scene, how bright is the everything else, is it correct? Just a lot of ways to verify everything. So it should be very, very robust. We're gonna have custom projection matrices and custom shadow matrices. So you can take so the custom shadow projection matrices are gonna be a little bit more user friendly to control, where the shadow matrices are gonna be more for cinematographers who kind of are more advanced, who know how to move the sun around over time and things like that through their shots. So the shadow matrices could be used to put the sun basically wherever you want and move it however you want over time, or as the camera moves, or really anything else. So it could just allow you to basically move the sun around however you want. It does not just required to the day-night cycle. It does completely override the day cycle inside of Minecraft. However, it will not override the actual like back-end game ticks. So like mobs will still spawn if it's nighttime, and like all of those effects will still occur. It'll just look like it's daytime. The projection matrices are entirely going to be controlled by the camera system. Currently in Continuum, whenever you update the focal length, the FOV does not adjust. And this is actually kind of a big problem for general overall feel of the image. So in 2.1, we're going to have not only noise for the ISO. By the way, you can turn all of these off if you don't want them. EV offset is still going to be a good exposure offset that will not have any adverse effects on the image quality. So the idea would be like as low, like 50 ISO, and then like just crank the EV like as high as you can if you really want a clean image. But anyways, higher ISO, more blur or more noise, more shutter or longer shutter times, more blur, things like that. Sadly, the motion blur is going to be limited to your frame rate. So if you're getting a really low frame rate, it's going to be a little hard to make it look just perfect. And if you're getting a really high frame rate, it's a similar story.
Does this include like a preset for long and short?
Yeah. So anyways, the way that you define out the camera in Continuum 2.1 is a lot more in depth than 2.0. So in this case, we actually are simulating many different lens types. So we have circular, doublet, triplet, and aspherical lens types for the bokeh. So all of these have, basically we're going from like cheap to expensive cameras, and how many corrections their initial lens has. Then we can go into things like the focal length, perfection, how much chromatic aberration, well, essentially we're going to be simulating all 7 aberrations that are inside of a lens. So you could push any imperfection that you wanted to give a specific feel or look to the camera and the way it focuses and the way it just handles the scene and lighting itself. So we're going to have a lot of pre-built options, so you can just go after specific film looks. Or if you want like a very bubbly or a very perfect disc off, or however you want it to look, there's going to be a lot of presets for that. And if you want to take manual control over each aberration effect, you can also do that if you know what you're doing in that regard. So the lens system is going to be a lot more complex, and as you change the lens, slight things are going to change with the FOV, with the vignetting, with all of the other effects that go along with the camera. So hopefully in 2.1, the camera will feel a lot more natural to anyone who's ever actually dealt with the camera, and it should feel hopefully even more at home than it already does now. A lot of words. For fuck's sake. So, yeah. Lots and lots and lots of good. In 2.1, the shadow Peter Panning should be gone, and there should be no visible acne. The shadow map should be as close to the block as it possibly can be. Currently, it's kind of throwing a few issues, but it is working to an extent.
We're gonna put profiles in, or at least an option to speed up and slow down the eye adaptation. Oh, I thought you were gonna like include a camera option that was like an eye instead of...
It's kind of hard to see, but as you can see, the shadow map gets extremely close to the casters. It gets about as close as it can get. No, there are some issues with it still, and I can show those off real quick.
I wasn't paying attention yesterday.
And diffuse, yeah. So we can just do sunlight without diffuse color or normals.
Having a good time.
So currently the issue with the shadow map here is this.
Oh no.
So you can see that it works sometimes and it goes right up to the edge, and you can see that sometimes it bleeds over. If we go to hard shadows, it works perfectly. It's just with other shadow types, and honestly, why is my UI size like absolutely massive?
Because
please stop.
You really like to feel like you're playing on a touchscreen?
There we go. I can actually read things. That's amazing.
I was very confused for a second because of the stream lag.
So if we go to hard shadows, oh right, I left it broken. Oops, give me a second.
Rip. Getting rude.
Weird. But anyways, when it's fixed, it should be very, 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 very close to perfect. It should be probably the closest it can be. And if needed, we can actually ray trace the bottom edge of it if it's too low resolution in the current state. That being said, I wonder what is the resolution? 2048. Weird. Anyways. So yeah, that's pretty much what's going on. So I just wanted to kind of go through like a little live kind of walkthrough of what's kind of going on, what we've been up to, what we've been studying. For the lens, by the way, for the bokeh shapes, we have complex shapes here. So it's actually kind of interesting what we've come up with in this regard. Is this the wrong? Oh yeah. Oh no, it crashed. Well, that's not good. So, sorry, I'm just trying to rethink about how I did all this. Okay, I remember now. I put everything up here. So these are the different lens types. So this here is a spherical lens. Energy distribution. You can see here we get this nice bubble in the center here.
There's a nice bubble.
So what this does is where can I? Where's a good example of bubble? Come on, is there one in just one of these papers here? I have. Well, I closed it, I think. Yeah. So we have this article here that goes over simulating the imperfections in geometric optics using fast Fourier transforms. This is a really cool method, in all honesty. This is mathematically really fun. This is in a separable form, however we don't use spherical bokeh shapes, so that doesn't work for us. But you can see here that these fast Fourier transforms have a real and imaginary part. Basically they're just simulating the interference here of a lens of common lens types. So here we have a circular, a doublet, and a triplet. And it goes over a lot of mathematics behind all of that. And you can see the differences in the bokeh energy distribution. A good way to think about this is if we have a disk here, this energy pattern will, or rather this like energy pattern here will distribute around the disk. So whenever you get those bokeh shapes, you'll get a lot less energy in the center, and you'll get a lot more energy around us. You can see as we add more corrections to the lens, we get more disc-like each time. However, we get more of these visible rings until we get up in the really high lens counts. So this one here is 5 components, and then this one here is 6. This is basically a perfect disc. Anyways, no one really goes past a third lens correction in real life cameras, just because at that point it just becomes cheaper to make an aspherical lens, and an aspherical lens will give a perfect disc in it every time anyways. So that's a really easy simulation. So we allow these 3 different types of lens patterns outputted to the final image here. So that's really cool. These also will define out the chromatic aberration patterns, so you'll get the distinct red and blue shifts and the green shifts. So rather, you'll get the red and blue shifts for this one. You'll get either a red or blue shift for this one, and then you could get a green shift for the triplet. And that's just the way that the corrections kind of go. Oh, I'm sorry. You get red and blue on the circular, you get green on the doublet, and you get none on the triplet. The triplet can fix all 3. So this is a really cool paper, and I honestly, or a little blog post. I believe, was it Frostbite? I think Frostbite did it. Was it Frostbite? I don't know, it was EA. They went over their circular separable convolution depth of field. This is a really cool depth of field method, and they honestly did some really cool things with it. Honestly though, for our use case, it wasn't quite what we were looking for. This would allow much larger blur kernels, but overall it's not going to be saving us very much in terms of configurability or performance in really many ways at all. So that sucks. But whatever, we did test and we found out that it wasn't good. So that's kind of what we've been doing here. Is there anything else, Jake? Do you really think? Is that pretty much
it?
That?
What even is understanding at this point?
Yeah. Something, whatever he said. I keep putting off this Windows reinstall.
Okay, so yeah, energy, clouds, weather, caustics, lighting, RT, legacy.
Show the people some pretty.
What?
So give the people what they want, Joey.
Well, the people want performance and they want pretty, so it takes a little longer. Sorry.
Just show them pretty for now.
Gib.
Give some pretty.
Gib.
Host and voice chat. We got Seth and Jake. So Shoal Shot and Jake Mitchie. Right, is that your name? Or is it? No, it's JCM.
What's Jake Mitchie? Like literally 20 minutes ago. I'm very confused. You just change it just cause.
He likes to watch the world burn.
You're right, Strom. You're right. You got it. You're right. No,
All right.
He's obviously New Zealander, right? Right, Jake? Are you a Kiwi?
Fuck off. Not a sheep fucker.
Oof.
So yeah.
Kangaroo flipper then, right?
No.
Oh, I also came up with I also have a few ideas on how to multi-scatter clouds, which is gonna be fun. I forgot to mention that.
Oh.
That's gonna make it look very nice. Gonna be nice and bright.
Can we get some Horizon Zero Dawn clouds, please?
These are actually gonna be a little bit, I think, more advanced. The only thing that Horizon Zero Dawn will ever have on us is their FBM generation, just because of our lack of resources for like sampler 3D and stuff.
That sounds like quitter talk to me.
Do you like performance? Because that's pretty much the only way.
Runs on a PlayStation 4. Come on now.
So, is there anything else that we got going on here? I'm keeping the same design philosophy that I did to 2.0. We're doing a fully PBR lighting system with a very in-depth post-processing system to allow you to get basically whatever look and effect that you want. Hopefully, though, with 2.1, with how good the user lib system is, we should have a few of our own internal user libs. They'll have LUTs and other things already predefined out, so you can have completely different looks kind of at will. So it should be good. So if you don't like if you like the flat look, you can have the flat look. If you want a very vibrant kind of very filmic look, you can have that. If you want the cyan orange kind of medium contrast look, that's also a possibility. I'm not saying that it's supported. However, with the way that we're designing Continuum, in the future here, we should be moving everything into 10-bit buffers. So that's going to be fun. Or rather, our lighting pass into 10-bit buffers. And what this is going to allow us to do is something very fun. I'm very, very excited about this. We're going to have very nice ACES. We're going to be rendering everything in full spectrum space. So if we ever wanted to, let's say, adapt the shader to output to like a DCI-P3, HDR panel, you could do so, or Rec 2020, or Adobe sRGB, or whatever color space that you want. It doesn't matter because every color space would be smaller than the original one. The downside to this is the textures that are being supplied are in sRGB, so they are limited on their range. However, all of the lighting, the sky, all of our effects, everything else, our color shifts, all of that is done in a large in a large buffer there. So that's going to be very, 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 very fun. So like HDR and all of that is going to be supported. I'm excited. Now, Optifine, of course, would need to support these outputs for that to work. I don't know if he would. I don't know if Nova is either. But we are designing it like this, not only just to output in the different color formats, but also to be able to have a more robust, reusable shader, just in case if we ever wanted to move to other games or anything else, we can still reuse a lot of our code.
Do it.
Yeah. Also, if we ever want to go on consoles or any other thing like that. Like, there's so many cases where HDR and other things should be supported. This also allows us to have really nice color on all of our tone mapping and everything else. So everything should update very nicely. Colors shouldn't like fully clip out and, you know, go pure blue or, you know, whatever else that might happen. So I'm trying to think of what else to say. God damn it, how long have I been streaming for? Oh my god, it has been an hour of explanations. Wow. Is there any new features coming? That is literally what I'm... Here, there's going to be a VOD of this. Go back and watch the VOD. It's literally been an hour of explaining. I'm sorry. But yeah, no, there's a ton of new stuff. Actually, well, okay, I can't say there's a ton of new stuff. It's like super refined, basically. It's Continuum 2, but everything that I kind of wanted it to be, basically. And everything that it couldn't be at the time, either because of my lack of implementation, time constraints, whatever else. It was already way late. So, anyways, yeah, I'm super dedicated right now. So we're churning through stuff.
Yeah.
So currently, what we're working on, the reason why I haven't gotten the 2.1 alpha out yet is because I wanted to have the new LUT-based guy in before I do that. And I also want to fix up the TAA and make it a lot more stable and a lot better. Hopefully get our performance up just a little bit more. Currently we're getting around... So the base with everything turned off gets around 450 FPS. I don't know what the performance of 2.1 is right now, but honestly any performance is going to be super skewed because the sky is now the absolute slowest thing in the shader by far. It definitely is the slowest. When we add ray tracing, that's also going to be very slow. We're going to need to work through that. AO is very light. The shadows are very slow, so I'm still working on hopefully ways to clean up the shadow map a little bit to only render what we need. So hopefully that would be nice. Does RT work on Intel HD? Absolutely fucking not. Like, no.
And even if it did, probably wouldn't support it anyways, because...
No. Just no.
Yeah.
No. Please no. I don't want. I really don't. That is the exact opposite of what I would want to do.
You're actually probably going to get less than 1 FPS.
Yeah, no, like the thing is... Well, I mean, it's going to be on the base, so it's going to be fast, hopefully, but...
Oh, no, not fucking RT. No, not RT.
Oh, what?
No, RT is gonna, Intel, RT.
Oh, Intel and RT? Oh, yeah, no. I mean, it would probably be more than 1, but it wouldn't be great.
Oh, no, I don't think so.
It wouldn't be playable. It would be around, it would be less than 5. It would definitely be sub 5. But yeah, Continuum RT is not going to support RTX, at least not immediately. RTX support would need to be integrated with either like Nova or some other mod that would patch it into the system. Currently, RTX is only supported through DirectX 12 and Vulkan. So we would need to be running in one of those contexts to even use it at all. So it's gonna be a bit of time before we could actually play with RTX. But RTX is definitely a consideration for us. That would be a lot of fun to play with. Those RT cores are kind of fun, and so are the tensor cores, and honestly the whole thing is going to be fun.
Yeah, but even then, until Nova comes, at least we're really only going to be able to play with like the tensor cores, because the fucking RT cores requires
no, same with tensor
volume hierarchy.
Tensor cores still require custom extensions. Yeah, you need to enable the extensions.
I don't even think Battlefield 5 uses them yet. Use their own denoiser, which is kind of dumb sounding.
Yeah.
I think they talked about it.
No, but the RT cores and RTX.
I'm probably going to make my own denoiser, and I'm probably going to make my own everything. I'm not going to lie. I'm definitely going to be doing that. It's not that I don't believe that theirs is great. It's just I believe that RTX, like their internal libraries, were designed for everyone. They were designed to be integrated in almost any engine or any subset of that.
And to make it easy to integrate.
Yeah, and make it easy.
Honestly,
we don't
probably Unreal centric too.
Yeah, we don't really need that at all. Like in the slightest. So we're gonna design it to be tailored exactly to our needs specifically. Love you too, Strum. Ugh. We should talk more. Get in contact. Say hi.
He says things in the server.
Does he? I never see it.
Not much.
I don't know if there's going to be a release by the end of the year, but that would be really cool if that happened.
I have not heard or talked to him and had him say by the end of any year ever.
Yeah.
Like, he doesn't give
times.
No, he's just now working on making it render something again. After his rewrite.
Yeah. Yeah, so Nova's gonna be cool. Well, yeah, I mean, we might have something rendering by the end of the year. I can see that. We might have something. I don't know if it's going to be good, but we might have something.
He's working on the shader translation too right now. So
yeah, he kind of needs.
It might be a little more than just the basic stuff we've gotten before, but it's probably still going to run better, I imagine.
Yeah.
And then the problem comes of porting Nova over to the Blaze 3D. So
programming is something that you've never programmed before is hard. I've been working with that when I've been dealing with the Skylight generation. So I've actually never made like a full OpenGL application myself, and I need a fairly actually complex one for this Skylight here. So yeah, it's been a learning experience. But I do have triangles. I do have shaders attached. I'm working on getting the compute shader the correct data right now. And I'm working on getting the JSON libraries all loaded up. After I do this though, I should have enough knowledge to make the texture packer. So that's going to be hopefully a really nice tool for Continuum to be able to preview your textures beforehand.
Good.
Gib.
Zombie, you need to get something that isn't a Chromebook first. Just saying. Big, fluffy, real 3D clouds, basically.
Yeah.
Yeah, volumetric clouds are clouds that are rendered in three-dimensional space. So they have, volume to them. They're thick.
Flew fly through them. Look at them move across the sky, all pretty wonderful. Rip FPS.
Yeah, I mean, I'm decent. I've gotten a lot better with Python, but I definitely realized quickly in developing this that Python is not the right language to deal with OpenGL in. It's just not.
No, it's not.
It's just not. Yeah. So all of our applications are going to be probably C++. Enjoy learning. I already learned C++. I've known C++ for a while. Rather, I've known the syntax. I didn't really know the standard library very well until recently, and I really didn't know the OpenGL API very well until recently either. But yeah,
Interesting.
y'all gamers gotta learn the cool hip languages. I mean, like, I don't know. I looked into Rust and I looked into Haskell and I looked into all these. Rust is super cool, but I feel like you should probably learn C++ before you learn Rust. Yeah. Honestly, my opinion has stood for a while that I think everyone should learn C as their first language. Because it gives you a really, really good insight into exactly what's going on inside of the computer. And then it makes you aware of all of the things that actually need to be happening in the back end. Where Java might allow you to be a little lazy and it might be very unideal for what you need.
Oh god, what is YouTube doing? Why is it...
Yeah, Rust is a nice language because it's very safe. It's very hard to get a seg fault in Rust.
I have faith in you. You can do it.
It's pretty damn hard, but...
I'm just... Huh.
But yeah, I think I'm pretty. Yeah, I learned Java as my first language. I very basic. Like, it was, my knowledge of it was very basic. I basically knew the syntax and a few other things. It wasn't so much later when I kind of figured out, like, programming, like, styles and fundamentals and how things should be laid out and performance, memory, everything else, all the other parts of dealing with an application. Okay, yeah, it's very easy to get a seg fault if you use the unsafe block. That's the fucking... That's literally the point. It is, if you're using the unsafe block, you are assumed to be an advanced user, and you know what you're doing. You're by putting that there, you're saying, I promise I know what I'm doing. And by putting that there, it also makes it very easy to debug, because you know exactly what the issue is.
Bruh. I'm trying to copy my documents folder to back it up, and it just stopped. It stopped, and there's no button. It says about 50 minutes remaining, and it's not moving at all.
Unsafe is based. There's a lot of operations and other things that aren't memory safe. So sometimes it can leave null, sometimes it can leave trailing numbers, sometimes it cannot delete properly, sometimes there's a whole list of things.
Jake, come fix this.
But yeah, I honestly, I think that's where I'm gonna wrap the stream here. I think that's pretty good.
I was literally about to say, like, I'm gonna have to go very soon.
Yeah, I think that's good.
This is the spider asking for its computer back.
So
Yes.
Those damn Australian spiders.
And it's looking very angrily at me. It's about to jump down at me.
Venom over there. That's you.
So yeah, so that's pretty much what's coming right now for Continuum 2.1. Builds should be coming out this month for it, though, for sure.
Get builds.
I don't know when this month. It could be the end of this month. It could be in a few days. I don't know. We'll see how it goes.
First build as a Christmas present.
Yeah. You know, or it could be in January, or you know, like next year. We'll see how it goes. No, in all honesty, no. It really should be an alpha this month for sure.
Don't worry, guys. I'll bitch at him.
There's no reason. Honestly, in its current state, I could put it out to alpha, but there's currently nothing really here that's all that interesting, in my opinion.
Nope.
And I want to have a strong launch for it, so I'd rather have some content available that people actually want when we first release it than just a in development piece of garbage.
Let's launch me, Daddy.
So yeah, we'll see all you guys later. Bye, stream.